Let's move on to the next exercise. Before we move on, let's look at some formula. Now, without the formula, we worked on depreciation where we use the interest formula but subtracted. Now, in case we are looking at depreciation of a machine, so formula would be value after n years. So let's say you want to calculate value after 2 years. This will be equal to present value, which is in this case we can look at P times 1 minus r upon 100 raised to the power n. This is if we want to calculate value after n year. Number 2, in case present value is given and you need to find the original value which was 2 years back, then you can write this as present value, which is today's value, is equal to value n years back, n year ago, 1 minus r upon 100 raised to the power n. Same thing, same formula can be used for increase or calculation of population, for calculation of growth. So let's look at for population. Now, if we are talking about population, the formula that we can look at is population after, let's say, n years. It'll be equal to, and if it is a growth, which means it'll be equal to present population multiplied with 1 plus the rate of growth upon 100 raised to the power n. So these are certain applications of these formula. Now let's look at solving some questions. So I'm on exercise 3D. I'm on question number 1. The cost of a machine is supposed to depreciate each year by 12%. So R is given equal to 12% at the beginning of the year. If machine is valued at rupees 44,000 at the beginning of 2008, so value of 2008 is equal to rupees 44,000. We need to find value end of 2009. That's my first part, correct? So between, and it's saying that depreciation happens beginning of the year. So how many years are we looking at? This is 2008, one depreciation will happen at the beginning, and beginning of 2009 another depreciation will happen. So in this case we are looking at n is equal to 2. So let's look at this formula, value after 2 years. So value of 2009, I'm using this formula. This one will be equal to present value, which is 44,000 times 1 minus r is given equal to 12 upon 100 raised to the power n, which is 2. 4 into 3, 4 into 25. So this will be 44,000 multiplied by 25 minus 3, that's 22 upon 25 into 22 upon 25. I've already done this calculation. The answer for this is 34,073.60. I repeat, decimal up to 2 places. Let's look at part 2 of this question. Part 2 says at the beginning of 2007. So they want value beginning 2007. So this is beginning of 2007, which means a depreciation would have happened in 2007. And this is value at beginning of 2008, which means depreciation hasn't happened, which means in this case we are looking at n is equal to 1. So now let's look at this formula, present value. In this case, V 2008 is present value. We want to know what would have been the value 1 year back. So 44,000 is equal to value n years back, which is value 2007 multiplied with 1 minus 12 upon 100 raised to the power n. In this case, n is 1. So this is 43425. So 44,000 is equal to value of 2007 multiplied by 25 minus 3 is 22 upon 25. Therefore, now we cross multiply. So value of 2007 would have been 44,000 into 22 upon 25. 25 1, and we do this calculation, and the value answer comes to be, oh, this is incorrect. I have not done this properly. This will be cross multiply. So this will be value 2007 will be equal to 44,000 into 25. This goes up. upon 22. So 22 1, 22 2000, 25 into 250. So this would have been 50,000. Thank you. Let me see if I have more time. So let's look at question 2. The value of an article decreased for 2 years at the rate of 10% per year, and then in the third year it increased by 10%. So year 2, year 1 is minus 10%, year 2 is minus 10%, and year 3 is plus 10%. So let's look at the formula. Present value will be equal to original value, in this case 1 minus 10 upon 100. Second year it was 1 minus 10 upon 100, and in the third year 1 plus 10 upon 100. So present value is given equal to 40,095. Original value we need to calculate. This is 10 minus 1, 9 upon 10. This is 9 upon 10, and this is 11 upon 10. Therefore, original value will be equal to 40,095 into 10 into 10 into 10 divided by 9 into 9 into 11. 11 1, this is 3645, this is 405, this is 45. This goes, this is equal to rupees 45,000. Thank you. Let's try and solve question 3. Question 3 says, according to a census taken towards the end of year 2009, population was found to be 64,000. So population in 2009 is equal to 64,000. The census finds that the population has a growth rate of 5%. So R is equal to 5%. After how many years after 2009 did this population reach 74,888? So the amount, which is population after n years, is equal to 74,088. So the formula that we'll use is 74,088. This is the amount, is equal to principal, in this case 64,000, 1 plus 5 upon 100 raised to the power n. This is 1, this is 20. 74,088 upon 64,000 is equal to 21 upon 20 to the power n. Let's divide by 8. So this is 8,000 and this is 9261. I know 9261 is 21 cube and 8,000 is 20 cube. So this is equal to 21 upon 20 raised to the power n. Therefore, n is equal to 3 years. So after 3 years, the population will change to 74,088. Thank you.